Hello, and welcome to my presentation. My name is Angelos Lazoudis, and I am a physicist and a senior researcher in the R&D department of Ελληνογερμανική Αγωγή. Since 2007, I have been implementing educational activities in primary and secondary schools, and today I will present you the Eratosthenes Experiment, a 2,300-year-old ingenious measurement. So let me please go to share my screen with you. And there have been many methods proposed for measuring the Earth's radius. This can go back, besides Eratosthenes, to Al-Biruni around 1000 AD. Al-Biruni was an Iranian scholar, and he lived during the Islamic Golden Age. And he proposed a method based on mathematics, and you can also measure the Earth's radius using more modern methods, like, for example, a video camera, as the paper that I present here. Eratosthenes was a geographer, astronomer, and also the chief librarian at the Library of Alexandria around 250 BC. He read that in the city of Syene, at a certain day in the summer, you could see the sun casted in the bottom of a well around the local noon. So by knowing that the Earth was round, Eratosthenes wanted to find how big the Earth was. So he measured the shadow that was created by the sun rays striking the top of a wall in Alexandria. And knowing that the sun ray was entering the well in Syene, he could find from the shadow in the length of the well, from the shadow cast at the length of the well, he could find this blue angle. This blue angle corresponds to the distance between Alexandria and Syene. So he measured that angle, and he found it around 7 degrees. He also measured the distance. He calculated the distance between Alexandria and Syene, which was around 5,000 stadia. And he made the calculation that if this angle, the 7 degrees, corresponds to 5,000 stadia, to what length does the 360-degree angle correspond? And that is the circumference of the Earth. And he found it very precisely around close to 40,000 kilometers, like the number that we know today. In our activity, we have the following objectives: to describe the geometry of how sunlight strikes Earth at different latitudes, to describe how the circumference of the Earth was first measured by Eratosthenes, to describe how to find local noon, and to measure the angle of the sun at local noon. And also, as an alternative, if we find schools that have the same longitude, to collaborate with another school and determine the radius of the Earth by exchanging data. The map tools that we use are the Google Earth or the National Geographic Map Maker. And in terms of calculators for the local noon, we have the solar calculators like the NOAA Solar Calculator or the Stellarium software. We performed the experiment during the spring equinox day because we know that at that day the sun rays cast no shadow on the equator. So we can use the equator as Syene in a similar way that Eratosthenes did his experiment. So we have a post, we measure the shadow of the post at the local noon, and we can find this angle theta that corresponds to the distance between our school and the equator. And from that, you can find, with a similar way, the radius of the Earth. Now, in the case that we have two schools, we can perform this experiment at any time during the year. You have two schools at a distance that share the same longitude. The first one measures the angle from the post and the shadow, which is the purple one. The second school, which is north, in our case, can be a school in Warsaw, while the other one is a school in Athens, Greece, measures this angle, the red one. The angle that corresponds to the distance between the two schools from Warsaw and Athens is the difference of the two angles. So by knowing the difference of the two angles and by finding through the map tools the distance between the two schools, one can find the circumference of the Earth. If you have schools that don't share the same longitude, this scheme shows you how you can calculate, how you can exchange data. You just have to take the projection of school B, for example, on school's A longitude, and then use this distance in your calculations. Here we see an example of a school in Athens collaborating with another school in Vantaa, primary school in Vantaa and Vantaa, Finland, that share the same longitude. Here you can see the activity taking place at the school. In the middle is the one in Athens, as you can see in the bottom, of course, with the snow is the school kids in Finland. And on the right, you can also see the shadow, how long the shadow is in Finland at that day. We have a website, the eratosthenes.ea.gr, where you can go and register your school, and we will try to find you and match you with another school. In 2019, we had 802 schools participating from 77 countries. Basically, we had participants from all continents, and I will show you later on some images from Antarctica. So the more schools we have, the better chance there is to find someone with the same longitude as you. So going down to Eratosthenes at Antarctica, we had a researcher there, and at Amundsen Scott Station, that was Robert Schwartz, and he has sent us some pictures. Since there was no pole there, he took a picture of himself, so you can see the shadow here. Robert's shadow is here, and Robert is about 183 meters tall, and he has estimated that the length of the shadow in this picture is more than 100 meters. Here, this is another picture that was taken by him on March 21st, 2019. Along with the Eratosthenes activity, you can find a lot of information and lesson plans on the website. We have a photo contest, so it's the Eratosthenes Experiment photo contest. So schools can participate by sending one picture, one photo, and usually this is teachers participating. And the winning photo, the teacher wins a trip to the D-Stars summer school with all expenses covered. D-Stars is a summer school that combines space exploration with digital storytelling. You can find more on the website. And here I would just show you a few photo contest winners. In 2015, we had two winners. One is from Ireland, Chris Garvey. The other one was from Croatia, Bojana Habek. Here are the two pictures. In 2016, Anita Simak from Zadar, Croatia. 2016 March, we had the two winners again, Petros Koutroulis from Naxos, Greece, and Paola Castagnoli from Ferrara in Italy. So thank you for your attention. This was a brief presentation. For more, you can go to our website and download the lesson plans. If you have any questions you would like to ask, please feel free to contact me. Thank you for your attention and for attending this presentation. Bye-bye.